This video will explore how to de-risk enterprise IT transformations by architecting reality. We'll look at synthesizing hardware modernization and cognitive psychology to target enterprise transformation leadership. IT transformations often fail due to bad assumptions, not bad code. We must address both systemic risks from legacy silicon and decision risks from legacy carbon or cognitive biases. An all-or-nothing migration is a recipe for cloud repatriation. In fact, 1 in 500 enterprises attempts a complete platform evacuation. The hybrid model is the most sensible reality. Leaders must avoid binary thinking. We must dismantle the rewrite everything fantasy. 80% of systems require no functional changes, while only 20% are true candidates for a rewrite. Ask yourself if you are modernizing a system that already performs perfectly. A workload classification diagnostic helps separate must-moves from leave-alones. Core transactional systems should be retained, while agile-dependent workloads are candidates for rewriting or replacement. Anticipating failure modes is crucial. For COBOL to Java refactoring, look out for performance degradation. DB2 to cloud native risks silent data corruption. Data replication for hybrid systems can lead to latency and data drift. Silent data corruption is a major unseen risk, particularly during naive bulk conversion from mainframe EBCDIC to cloud ASCII/Unicode. Never accept simple record counts. Demand field-by-field checksum reconciliation for critical datasets. Building a defensible cost model means modeling the hidden depths of costs. Don't just compare MIPS to vCPUs. Instead, compare a fully loaded mainframe baseline to a fully loaded 5-year cloud projection, including parallel run expenses and staff retraining. Hidden psychological forces can derail software engineering. Research identifies 37 distinct cognitive biases, such as anchoring, confirmation, and overconfidence, that systematically sabotage IT initiatives. These are predictable flaws in human reasoning. Cognitive vulnerabilities in engineering include stability, action-oriented, interest, and pattern recognition biases. These lead to persevering with flawed options, premature decisions, distorted reasoning, and focusing only on familiar information. The software development hazard map shows biases at different stages. Anchoring bias affects estimation, availability bias impacts design, and confirmation bias risks testing by avoiding efforts to break the system. Mainframe exits fail due to cognitive root causes like optimism bias, status quo bias, and anchoring. These result in business failures like trusting vendor fantasies, refusing to exit "black boxes," and botching phased migrations. Systemic IT failures are symptoms of unchecked human heuristics. We must debias the task, not the person, using dual-loop learning. The actionable framework suggests planning poker for anchoring, rigid traceability for confirmation, and generating multiple design solutions to cure overconfidence. To hardwire against optimism bias, shift from the flawed default of time and materials contracts to a debiased contract. This should be milestone-based with a 110% baseline performance SLA and value-based data reconciliation to shift financial risk. When architecting the pilot, do not start with the easiest application. Select a right first mover that uses representative tech, stress tests the toolchain, and has a balanced, meaningful risk profile. This proves the architecture in a low-risk environment. The Go Live scorecard defines success beyond just, "it works." Key metrics include performance at 110% of baseline, cost accuracy within 15% variance, mainframe equal operational stability, and 100% field-by-field data fidelity. Modernization requires a proven migration factory.